Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we are going to continue our tutorial 7 again. Number 6, still number 8. Hope you are still in a good spirit, in a good condition, and in a good health, despite on the challenge that we face in this pandemic. So keep calm and study physics. Let's see, number 6, a cooling fan is turned off when it is running at 850 revolutions per minute. It turns 1500 revolutions before it comes to a stop. Right, so let's see, initially for omega naught is 850 revolutions per minute and then it comes to a stop. So this is omega. This 1500 is theta. The question asks for acceleration or angular acceleration. So we can use here as. Okay, so we can here use as because omega is 0. Omega naught is omega naught is initially 850 revolution per minute. So we change it to radian, times it with 2 pi times 60. So what we get, 850 times 2 pi, 850 times 2 pi divided by 60. We got 89 radian per second. And then the question gives us theta in revolution. So times it with 2 pi to get the SI unit radian. So times it with 2 pi because 1 revolution equals to 2 pi radian. So we got 9,424.78 radian. Okay. So now substitute the value in the equation. So 0, 89 squared plus 2 alpha theta. So therefore alpha is 89 squared divided by 2 times 9,424.78. So we get negative 0.42 radian per second squared. Okay. Okay, let's see number 6b. How long did it take the fan to come to a complete stop? So say complete stop, how long? So complete stop means omega final is 0 and the question asks for how long. How long is time. Okay, so we already got the rate of acceleration, which is negative 0.42. So we can use what? So what omega is 0. Omega is 89. Alpha is negative 0.42. And time. Therefore, the time is 89 divided by 0.42. So we got 211.9 seconds, or maybe 212 seconds. Okay, number 6 is so easy. Okay, so let's see number 7. A small rubber wheel is used to drive a large pottery wheel, and they are mounted so that their circular edges touch. The small wheel has a radius of 2 cm and accelerates at the rate of 7.2 radian per second squared, and it is in contact with the pottery wheel radius 25 cm without slipping. Calculate A, the angular acceleration of the pottery wheel. Okay, so let's sketch how the situation is. So we have the large pottery wheel, and we have the small rubber wheel. This small rubber wheel touch the pottery wheel at one point. So at this point, there is tangential acceleration for both wheels. So let's assume tangential acceleration of rubber wheel and pottery wheel is equal because they touch with each other and they rotate at the same tangential acceleration. So we know that the um, relationship between angular acceleration and tangential acceleration is alpha, is R alpha for rubber wheel and R alpha for pottery wheel. Okay, so knowing that radius given for rubber is 2 cm, so 2 times 10 power of negative 2, change it to meter, and then we know that the acceleration for rubber is 7.2 radian per second squared, and radius for pottery wheel is 25 times 10 to the power of minus 2, but the acceleration is the one that we need to find. Okay, so use your calculator and find the angular acceleration of the pottery wheel. So 2 divided. So I got 0.576 radian per second squared. Okay, so this is the answer. The concept here is this one. Okay, this is the concept, 1 mark. The concept here is tangential acceleration of both wheels are the same. Okay, and then when we know the concept, we just substitute the formula of tangential acceleration. Okay, for both wheels, R alpha, R alpha. Okay, so that's all for 7A. So let's see 7B. 7B asks for the time it takes the pottery wheel to reach its required speed, 65 RPM, if it starts from rest. So it said that it starts from rest, therefore this is omega naught, and then the final is 65 RPM, this is omega. So we've got the alpha just now, the question asks for the time. So we can use ρ. So omega is 65 RPM, change it to 2 pi over 60, so that the unit will become radian per second. So 65 times 5 over 60. So okay, omega is 0 just now. So 66.81 equals to alpha 0.576. I'm the one that we need to find. So time is divided by 0.577 seconds. Okay, so that's the answer for 7B. Okay, so let's see number 8. The tires of a car make 65 revolutions as the car reduces its speed uniformly from 95 km per hour to 45 km per hour. The tires have a diameter 0.8 meter. Okay, the question asks for angular acceleration. It gives us theta here, it gives us u, it gives us v, and the diameter. Okay, remember that how do I know this is 95 kilometer per hour is U, because the unit kilometer per hour is actually not the rotational motion, it's actually for linear motion. So that's not omega naught, that's basically U. Okay, so we got a lot of work to do here. The first thing is we need to list all the information that we've got. So we've got 65 revolution, theta, change it to radian, so times with 2 pi, therefore we've got 108 radian. And then we've got U here, U 95 kilometer per hour. We don't want it to be in kilometer per hour, we want it to be in radian per second, so that, sorry, we want it to be in meter per second, so that it is easier for us to relate with the angular velocity after this. So 1 hour, 60 to 60 times 1000 meter divided by 1 kilometer. So we can cancel out this one. Fine. Okay, so let's say it's 26.4 meter per second. For V, we've got 45 kilometer per hour, and then we change it to meter per second. So what we've got here is 1000 divided by 2600, 12.5 meter per second. Okay, this is still not not rotational motion. This is still in angular linear motion. So we need to change it to angular motion. So use the relationship. V is equals to R omega. If you still remember, the relationship between linear motion and angular motion is V is equal to R omega. So let's say we use U is equal to R omega naught. So we've got U is 26.4. The radius is 0.8 divided by 2, so 0.4 here. So radius is 0.4. So what was the omega naught? Okay, 26.4 divided by 666 radian per second. Okay, V, so we got V is equal to R omega. So V is 12.5, R is 0.4, therefore omega 51.25 radian per second. Whew. Okay, so now we've got omega naught and omega. What we're gonna do now is find the alpha. So let's use us. Okay, so omega is 31.25 squared. Omega naught is 66 squared. Alpha is the one that we need to find. Theta is 408. So alpha is 31.25 minus 66 squared divided by 408 times 2. So we need negative 4.14 radian per second squared. So finally, yeah. Okay, let's recap what I did. So the first thing is I find the theta in radian. So I got 408 radian. And then the initial velocity, The question gives the linear velocity, that's the angular velocity. So the first thing I did is change it to meter per second first for both velocity, and then find the relationship because we don't want linear velocity, we want the angular velocity. So find the omega naught and omega using the relationship, and then final step is substitute all the values in the right equation of mass. Okay. Okay, so let's see the final one, 8b. If the car continues to decelerate at this rate, how much more time is required for it to stop? So it says time. So the question asks for the time to stop. Stop means omega is finally 0. Okay, so we can use what? Okay, but let's use um, omega 0 because when it comes to a stop, omega naught, let's use 31.25 instead, okay? Because from 31.25, it's going to continue to this rate until it stops. So 31.25 plus negative 4.14 find the time. So the time is 31.25 divided by negative 4.14, 4.14. So we've got 7.55 seconds. So that's all. Hey class, that's all for today. Till meet again in the next class. Bye.